What kind of galaxies have you studied and why?
We fundamentally wish to understand galaxies like our own Milky Way. Here we see it over the Atacama Desert in Chile. We wish to understand how these galaxies are formed and also how they evolve. In this work, we have studied some very distant galaxies, like the ones we see here. These are all galaxies and not stars. These galaxies are so distant that we see them as they looked 10 to 12 billion years ago. This is how long time the light has been on its way to Earth. This way, we get a direct view of how these galaxies looked in the very early times of the history of the universe.
How do you observe these very distant galaxies?
We use a very powerful technique that involves the use of a background quasar, as we see it here. These quasars are very luminous objects that can be seen out to very large distances. And sometimes we have a lucky alignment of the quasar shining through a galaxy on its way to Earth. The light from the quasar, as seen in the spectrum here, gets absorbed in the galaxy, and this way we can determine the content of this galaxy. And furthermore, we can determine the content of atoms that were formed in stars. These elements are heavier elements than hydrogen and helium, for instance, carbon and oxygen, and these are only formed inside stars.
What does your investigation show?
Our study shows that galaxies in the early times of the universe, roughly 2 to 3 billion years after the Big Bang, show a wide range of contents of heavier elements. And most interestingly, one of the galaxies that we found is very enriched in heavier elements. In fact, it is as rich in chemical elements as our own Sun. But not only that, the location of the galaxy where we find this high abundance is roughly 50,000 light years from the centrum. This means that the galaxy is very evolved, even in the outer parts.
What are the perspectives of these findings?
One of the perspectives that extends beyond our main ambition of understanding galaxy formation is that the conditions for making planets, such as our own Earth, which mainly consists of heavy elements, were present surprisingly early in the universe, and thereby the possibility for life to form.